Hey guys. So I hope you had a great break. We're going to jump back into things here. We're going to finish off chapter 8 with this lesson, and then we'll prepare for an eventual test on chapter 8, probably early next week. So we'll have a couple review assignments this week, and then I'll figure out the best way to administer the test. Perhaps we'll do it with some parent supervision. Maybe I'll put a portion of it online. So I'm still thinking about that, but we are about to finish the vaunted chapter 8, and then we'll kind of see what we can cover over the next 6 weeks or so of school, to kind of get a good chunk there of kind of early Algebra 2 stuff out of the way. Okay, so the last thing we talked about before break was direct variation. So if we look at the board here, when we're dealing with a direct variation problem, first of all, we need to remember that the relationship between a direct variation situation is if one value goes up, the other will go up as well. That's the direct relationship. An increase in one will equal an increase in another. The problems that I assigned before break were set up in this fashion, right? X sub 1 over y sub 1 will equal x sub 2 over y sub 2. What that meant in practice is that the problem would usually give you 3 items, and the 4th would be the variable for which we were going to solve. So if you open your books up to page 395, take a look at number 8 as sort of a refresher example. Let me read the problem to you right now. A restaurant buys 20 pounds of ground beef to prepare 110 servings of chili. At this rate, how many servings can be made with 30 pounds of ground beef? Now this problem doesn't actually use that word varies directly, so you have to kind of pay attention to the scenario, but it's in the direct variation section, so you probably know that it's the same kind of problem. In any case, they give us 3 things: 20 pounds of ground meat, 30 pounds of ground meat, and then 110 is it pounds, gallons? How do you measure chili? Servings, sorry, okay, 110 servings of chili. With the unknown being how many servings would you get with 30 pounds of meat, okay? We discussed how when we have a fraction equaling a fraction, we can cross multiply, which if we do here, we get 3,300 equals 20x. Divide each side by 20 to isolate our variable, and we get x equals 165. So 165 would go right there, and then that would have a kind of complete proportion. Okay? So again, without any numbers plugged in, that's the setup we're looking at for direct variation problems. Okay? So let's go forward now to 8-10, the last unit in this chapter, and we're going to talk about inverse variation. Okay? As I said before break, if we're going to kind of visualize the relationship in an inverse situation, if one thing goes up, a corresponding thing will go down. Okay? So direct variation is 2 things coming up. Inverse is one thing going up, the other going down. So an inverse movement. Okay? So take a look here. The kind of generic setup for an inverse variation problem looks like this. Okay? The convenient thing is we still have sort of 4 spaces. We have x sub 1, y sub 1, x sub 2, y sub 2. So there are still 4 spaces. And sure enough, in these problems, they're going to give you 3 things, and the remaining unknown is the variable for which we're going to solve. So open your books or go forward in your books to page 401, number 8. Let me read that problem out. The number of plants used to fill a row of given length in a garden varies inversely. So look, they give you that little hint there, right? Varies inversely. It varies inversely as the distance between the plants. So the wording there is a little tricky, but just again, the key is varies inversely. That's the word you need to see, and your brain needs to kind of light up and say, oh, it's an inverse relationship. Here's the meat of the problem. If 75 plants are used to fill the row when planted 20 centimeters apart, how many plants are used to fill the row when planted 15 centimeters apart? All right? So if we got this big row in our garden, and if we do a plant every 20 centimeters, we can fit in 75 plants, okay? If we decrease that amount to every 15 centimeters, we're probably going to be able to fit in more plants, right? So let's see how we set this up. So again, we want to pair things up properly. So in this problem, it's 75 plants when they're planted 20 centimeters apart. So let's make those our X and Y, I guess we'll call them values. But so we've got plants in centimeters. So we can do 75 plants. I'm going to use parentheses to indicate multiplication. Let's see, that was at 20 centimeters. Okay, so we've taken two of those three pieces of information and plugged them in here. That's going to be a plant number. That's going to be a distance. Okay, now go back to the problem, number 8. How many plants are used to fill the row when planted 15 centimeters apart? So again, working from our kind of generic setup example, we'll call it X, I guess. We don't know how many plants if they are 15 centimeters apart. Okay, so let's continue through the problem here. We've got 15x, okay? Then we've got, what's that going to be? Let me pull up my calculator because my brain's a little bit fried, and we're going to get 1,500. Okay, so that's where our equation sits at this point, all right? So we go ahead and divide each side by 15. That cancels, our variable is isolated, and we get 100. Okay, so again, 4 spaces. The problem gave us 3 pieces of information. They gave us this, this, and that. And whatever's left over, the unknown that's left over is what we're solving for. Now, let's talk about the inverse part of this so we can kind of identify that. I'm going to replace that with our answer. Okay, let me rewrite that real quick just so we can understand what's going on here. Okay, now notice what happened here. If we have 75, and we increase that to 100, 20 becomes 15. So if 75 goes up to 100, 20 goes down to 15. There's that inverse movement, okay? As the number of plants increases, the space between those plants must decrease. And that makes sense, right? Because if we have a given amount of space, right, and we want to fit a bunch of plants in there, well, if I'm going to put 2 plants in this space, I'll have one like here and here, all right? Let's say they've got, I don't know, let's say they got 10 inches between them. If I want to put 4 plants in there, it's going to be here, 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 and here. They're not going to have 10 inches between each plant anymore, right? They're probably going to have 2.5 inches because we take 10 and divide it by 4. I'll ignore that part. I'm just thinking off the top of my head. The point is that if we have a given amount of space, we want to fit plants into that space. The more plants we use, so as that number goes up, the space between will have to go down, and we have an inverse relationship, okay? So your assignment is going to be numbers 1 through 6 from this set, these inverse problems. You're basically going to follow this model for all of them. And once we've done that, we'll have covered in at least a kind of basic way the entire chapter, all right? So that'll allow us to start looking at review and work towards a test in Chapter 8, okay? As always, check in on Google Classroom. I'm on it every day, so if you do run into questions, I can get back to you pretty quickly, okay? All right, guys, hope you're doing well.